Hey guys, welcome back to the channel. So for today, I have a new showcase for y'all. I've been experimenting with a few different things on my engine. First of all, I've been working on trying to get an even better intake manifold. I have this one right here put on the engine right now, but it's not the best. I think there's just a lot of air leak going through here, and this kind of throttle body isn't the best for my engine. It still keeps it at 2400 RPM, but I'm actually trying to go higher than that. I've been able to hit 2500 RPM, but it only hit that once. I haven't been able to hit 2500 again, so I've just been trying to hit that RPM again and seeing what I can do. So I actually have a version of this intake manifold without the throttle body on it. It is this one right here. So as you can see in here, there's a lot of barely any blockage for airflow. It's just super direct from where the vacuum goes to the valves here and down there. Also added these holes in here to keep the engine from falling apart. So now I can just shake it like this and it won't fall apart. Before, it was really fragile, but yeah, the pins really help, and I'm hoping that without there being any air leaks at all, I'm hoping that this will be the best intake manifold that I can get for it, that I can make for it, sorry. So I'll be putting that on there. For reference, this is the one from last video. It's a little bit taller, but more smooth going down from the vacuum. But where the valves go, it's a little bit less direct, and there's less room for air to flow, I guess. So for comparison, the one on the right is the new one. I'd say it looks like it's even smoother than the previous one, so I'm thinking that it should help. And then additionally, as you can see, the pistons are white. That's because I have ABS filament, which is ABS is what Legos are made out of from the factory, but they're also 25% lighter than this black material, which is PLA. So I was hoping that ABS pistons would be even better, but as you can see, they're kind of warping. It's a little bit hard to tell, but they're definitely warping, and I'm thinking that that's hurting performance. So I reprinted that version of the piston in PLA. I have two of them that I'm going to put in here as well. But as you can see, this is the only part, apart from here on the sides, this part right here is the only part that touches the sidewalls now. So there's barely any friction at all on these pistons. So that should help a lot. With these pistons in here, that was when I was able to get 2500, but I'm almost wondering if because they warped, if that's why I only hit it once. But PLA it shouldn't warp like this, because ABS is really bendy, but PLA is really strong when it doesn't break, and they haven't broken. So I think I'm just going to stick with PLA for the pistons. I haven't made 3D printed valves yet, but I'm not sure how much I would need them, because I just don't think that they would help performance all that much unless I made them lighter somehow. Also, the last thing, as you can see, the crankshaft pieces for the valves here and here, they're also 3D printed, but what's new about them is normally on Lego engines you would have 90 degrees ahead valves, but I made them to where these are 115 degrees ahead. And the thing about that is that because they're even more advanced than they used to be, it helps with torque a lot. So there's a lot more low end torque, and I've gained 150 RPM at least from that. This combined with these pistons, that allowed me to get even higher than 2400 RPM. But I haven't been able to hit that since, so I'm hoping that in this video we'll be able to hit that again, or even up to 2600. But yeah, let's get started. So the pistons are a little bit rough, so I'm probably gonna have to take them back out and trim the sides a little bit. I already trimmed them a little bit all the way around the edges, but I'll probably just trim them some more to make them extra smooth. Yeah, hopefully that'll be enough. Alright, so I shaved down the sides of the pistons a little bit. I got everything put all back together, and needless to say, this engine is extremely smooth. So I'm hoping that this will break 2500, maybe get up to 2600, because I know it can. It just needs to be in the right conditions, and right now I'm pretty sure it is. But before I say too much, let's just see how it does and do some RPM tests. y'all, so that was genuinely insane. I didn't even expect it to go to 2600, but it barely made it to 2600. That's crazy to think about it. I mean, this is a long stroke engine, a long stroke, and some short stroke engines don't even go that high. I mean, most do, but some don't. I mean, still, this is absolutely crazy to think about. Before I did all these upgrades on this engine, it was barely making 1700 RPM, and I mean, as y'all saw too, I could barely stop it. Like, it was burning my fingers to stop it. Like, I was squeezing hard. Like, this engine is so powerful. It's crazy. And I mean, this was without oil too. I didn't put new oil in here. There was still a little bit left over, but I didn't even put oil in here, so the valves had no oil. The pistons had a little bit, so, but I mean, this is insane. I mean, you can't deny this is insane. But yeah, I think that's all I'm gonna do with this engine. As for the upgrades, I'm probably gonna do like gearbox runs or something like that with this engine. I'm definitely gonna do kind of like more advanced runs with it for sure. But if y'all want the 3D printed parts for yourself, I'll be linking them in the description along with some instructions for how to use them. But yeah, thanks for watching. Thanks for joining me on the series. And yeah. Don't know where I act, need some money in the city where the bags at. Took her out of work and now she never going back to it. Said it feels better when you come and put your hands on it. Oh yeah, don't have no money so you spending mine.